All right, so you ever watch a plane like take off
Yeah.
and wonder how in the world that thing is like defying gravity?
Huge.
It's huge.
Yeah.
Today, we're going deep on the theories of aviation,
I like it.
and we're going to try to make it really simple.
Yeah.
So think of this as your fast track to understanding flight, like the core principles
Right.
that keep aircraft up in the air.
The magic of flight.
Yeah, so we're going to cover things like lift and movement and stability and the wild world of supersonic speeds.
Mm-hmm.
We'll talk about how jet engines work.
Yeah.
And also how modern technology kind of plays a role in all this.
It's changed things a lot, hasn't it?
Oh, yeah.
Especially recently.
So the idea is that after this deep dive, you'll have a really clear picture
Absolutely.
of what's going on up there.
Yeah, so we're not trying to make you an aerospace engineer or anything like that,
Right.
but just to give you the essential understanding of
Yeah.
what's happening when you see a plane flying overhead.
So to get us off the ground,
Let's do it.
let's start with that fundamental force that gets those wings working,
Mm-hmm.
lift,
Yes.
which is driven by Bernoulli's principle.
Bernoulli.
Okay, so Bernoulli's principle, now I've heard this before, and I think a lot of people have too.
Right.
It's that the shape of the wing is like super crucial.
Yeah, it is.
And the idea is that because the top surface of the wing is curved, the air has to travel a longer distance
Yes,
than the air underneath the wing.
you got it.
So what's the surprising bit there?
Well, the interesting thing here is that while that difference in how far the air has to travel
Okay.
does contribute to lift, it's not actually the whole story.
Yeah.
Yeah, the faster moving air above the wing leads to lower pressure
Uh-huh.
compared to the higher pressure below the wing.
All right.
And it's this pressure difference that really generates lift.
Okay.
But there are other things that factor in too, like the angle of the wing and how the air gets pushed downwards or downwash.
So it's a little complicated.
Yeah, a bit more nuanced than just longer distance equals lower pressure.
Yeah.
It's still debated, actually, all the factors that go into it.
Interesting.
Yeah.
Okay, so we've got these massive machines.
Yeah.
Multi-ton.
It's huge.
Huge. How do they actually move forward?
Right, so that's where Newton's laws come in,
Okay.
particularly the third one.
Okay, Newton's third law.
Just think about the force coming out of a jet engine.
Oh, yeah.
It's expelling hot gas backwards with so much momentum.
Crazy.
I know. And Newton's third law tells us that for every action, there's an equal and opposite reaction.
Right.
So that blast of gas going backwards creates a huge forward push
Okay.
on the aircraft, and that's what we call thrust.
So push gas back, go forward.
Exactly.
Makes sense.
It does.
But I'm guessing it's not just thrust and lift that are involved when a plane is cruising up at, 30,000 feet.
Yeah, there are some other forces at work up there.
Okay, fill me in.
So we have four key forces that are always interacting.
Okay.
Lift, which we talked about.
Yeah.
Weight.
Yeah.
Which is that constant pull of gravity. Thrust, which propels the aircraft forward.
Uh-huh.
And drag, which is the air's resistance.
Okay.
So to get a plane off the ground, thrust has to be greater than drag, and lift has to overcome weight.
Okay.
And then when it's cruising, it's this delicate balance of all four forces.
Wow.
And when it comes time to land, pilots have to carefully manage all of these to bring the plane down safely.
And so I imagine all this is happening
It is.
while the plane is also trying to, not wobble all over the place.
Right.
So that's where stability comes in.
Yeah, so there's a difference between just being stable
Okay.
and what we call dynamically stable.
Okay, so let's break that down.
Yeah, so static stability is an aircraft's tendency to return to its original position after a disturbance.
Yeah.
Like if it gets hit by some turbulence, it wants to go back to how it's flying before.
So a self-correcting mechanism.
Yeah, exactly.
But what about dynamic stability?
So dynamic stability is all about how the aircraft behaves over time.
Okay.
Does it smoothly return to that stable position? Or does it kind of overcorrect and oscillate back and forth?
So it's the difference between a seesaw that settles quickly versus one that keeps rocking forever.
That's a great analogy.
Thanks.
And then on top of that, you have the control surfaces.
Okay, what are those?
So these are the moving parts on the wings and tail
Okay.
that allow the pilot to actually control the aircraft.
So you've got the ailerons.
Ailerons are for rolling the aircraft.
Right.
Elevators are for pitching the nose up or down.
Uh-huh.
And then the rudder is for yawing or moving the nose left and right.
Okay, so that's how the pilot can actually fine-tune the plane's direction,
Exactly,
attitude, and all that.
Yeah, they're constantly making small adjustments
Gotcha.
to keep the plane flying smoothly.
So those are the basics, right, for staying up in the air and moving around at, regular speeds.
Right.
But what happens when we start pushing the boundaries of sound?
So Breaking the sound barrier, that's a whole other challenge.
Wow.
It's not just about going faster.
Okay.
Because as you approach the speed of sound, you enter what we call the transonic range.
Okay.
And this is where some of the airflow around the plane is actually slower than the speed of sound, and some of it's faster.
Oh, wow.
Yeah, and this creates these shock waves.
Shock wave.
Yeah, they disrupt the airflow, and they can dramatically change lift and drag.
Wow, okay.
And then once you actually exceed the speed of sound...
So supersonic flight.
Supersonic, exactly.
Okay.
Then different aerodynamic principles come into play.
Right.
Shock waves actually become like the main force
Oh, wow.
shaping the airflow.
So it's a totally different ballgame.
It really is.
And what about the engines that make all this possible? What about the jet engine?
So jet engines are fascinating pieces of engineering.
I bet.
They work on a principle called the Brayton cycle.
Okay, Brayton cycle. What's that?
So it's basically a continuous loop of 4 processes.
Okay.
First, air gets sucked into the engine,
Okay.
and then it gets compressed to a very high pressure. Then fuel is injected and ignited, which heats the air even more. Yeah. And finally, this super hot, high-pressure air gets blasted out the back of the engine.
Gotcha.
And that creates thrust.
So from those really basic physics
right.
to this amazing, feat of engineering.
It is amazing.
Pretty wild.
And then you add modern technology into the mix.
Yeah. Okay,
yeah.
So how has that changed aviation?
Well, one of the biggest advancements has been the introduction of fly-by-wire systems.
Okay, fly-by-wire. So what's that?
So in the past, the pilot's controls were physically connected to the aircraft's control surfaces. But with fly-by-wire, the pilot's inputs are sent electronically to computers that control the control surfaces.
So there's not like a direct physical connection.
Exactly. It's like having an invisible co-pilot making constant adjustments.
That's wild.
To ensure a smooth and safe flight.
Okay.
Yeah. So this allows for much more precise control. And it also enables all sorts of safety features that wouldn't be possible with purely mechanical systems.
So it's this like amazing combination of physics and engineering and now like really sophisticated technology.
Right.
It's easy to kind of take it for granted, I think.
It is.
We just kind of hop on a plane and go.
Yeah, no.
But when you think about it, it's pretty amazing.
It is.
It's really a testament to human ingenuity.
I agree.
But I think even more than that, this quest to achieve flight has driven innovation.
Absolutely.
In so many different fields.
Oh, yeah, like advanced materials, complex software, you name it.
It all kind of stems back to this.
It all goes back to that desire to fly.
All right, so I want to leave you with this.
Okay.
Think about all the principles we've talked about today. From lift to thrust to stability, supersonic flight jet power, and fly-by-wire.
A lot to think about.
I know it is, but I'm curious, out of all of these, which one sparks the most curiosity in you? And how might a deeper understanding of that specific area unlock even more incredible advancements in aviation in the future? Well, thanks for joining us for this deep dive into flight.
Yeah, thanks for having me.
I hope you learned something new. And
me too.
Maybe even feel a little more inspired.
Absolutely.
The next time you see a plane soaring through the sky.
Yeah, it is pretty amazing.
It is.